Hey guys, welcome back to a new lesson of Catalyst concepts. Today we are going to talk about a new chapter and we are going to start the chapter right after periodic table, and that is your lesson number 8. We call it, I think, electric current or electricity or current electricity. All of them mean pretty much the same thing, right? So we'll start this chapter off today. Now, this is something that we have mildly studied in our previous grades, and I think in 7th and in 8th class, you'll have slight indications about this topic. Right? We use electricity every single day of our lives to burn our lights, our fans, charge our phones. All of this needs electricity, right? And pretty much the whole world runs on it. I mean, an hour or two without electricity is really difficult for us to, tolerate, right? So electricity is pretty much an essential part of our lives, and today we are going to start trying to understand what exactly is this electricity and how does it work. Now, we know there are multiple forms of electricity, right? We know we can get it on the power sockets. We also know that we can use batteries for electricity, right? Like vehicles have, or like your remotes and stuff have a small battery in them, right? We have also learned, I think, in 7th class that batteries store energy in some form, chemical energy we call it, and it changes it to electrical energy when you connect it to wires or something, right? So we're going to try to like build off on the knowledge that we already have about what a battery is, how it works, and what is needed for our current to pass through, right? So I'm going to draw a very simple basic diagram for you over here. All right. So if I have a battery like this, I'm just going to draw a very rough battery diagram here. Right. So this is the positive, this is the negative. This is how battery looks kind of, right? Now, if I have a battery, I can connect like two wires, and one from the front, one from the back. This is something we must have done a lot of times in our childhood. And then we just connect it to like a little bulb. And that bulb, what happens when we connect the battery to that bulb, right? It kind of just glows, right? So we know that there are two essential things that are needed for this electricity to make something work, something like a bulb. One is this battery, which is nothing but our source of power. And the second thing are these wires that we are using, right? We call them as conductors. Okay. We need a power source and we need conductors also to work. If you replace either of these things with something that doesn't work in the way they do, it will not work. For example, if I just take a bulb, right, simply and just connect it to wires, will it work? Like just wires and a bulb without a battery, it's not going to work, right? So this is not going to work because there is no power source in here. Similarly, if I take a bulb, right, and then I take a battery, but I don't connect it with wires. Okay. What I'll do, I'll connect it with something like a thread, the thread that we use for stitching clothes and all, right? If I connect it with thread, will it work? I don't think so, right? Thread is not going to work even though the battery is a power source and the bulb is there connected to the battery through something, right? The simple reasoning is thread is not a wire, right? Wires can work with electricity, but threads cannot, right? Thread is not a conductor, but wires are conductors. Now, let's try to understand why exactly these conductors and this power source are needed for this electricity aspect to work, right? So, power source and conductors. Right, I'll just put the words down there with this horrible handwriting. Don't mind. Okay, so let me talk to you about two scientists called Drude and Lorentz. Drude, it's not Dude, it's Drude. Okay, Drude and Lorentz. So what Drude and Lorentz said is, electricity is nothing but the movement of charged particles. Okay, they say it's a movement of charged particles, and according to them, metals have a lot of free charged particles. They can be, mostly they say they are electrons. Okay, so they say metals have a lot of free electrons that move around uh, ions of metals. Okay, so he says that if you take a piece of metal, those atoms in the metal, some of them are like ions because their electrons are a little loose. Okay, and they become free. So once these metals lose the electrons, the atoms become ions, and the electron is just like running around. Okay, so these ions form a sort of a structure. These ions that are connected to each other, they form a structure called a lattice. Okay, lattice is nothing but like a connected structure. Okay, don't just focus too much on that word. So metals are able to conduct electricity because of these charged particles that are free electrons. Okay, so a conductor is anything that has free electrons that can pass through that object. Okay, so it's not only metals, there will be other examples also. Metals are just something we use commonly. Okay, now whenever you apply current or power source to these conductors, the electrons are going to do something for the current to flow. All right, so I'll talk about a wire. All right, so if I take a wire, okay, think of this as a wire. Okay, if I cut this wire and I look at this end, right, this once you cut it, it's like kind of cutting a beanstalk and looking at it from the back. You'll see like a small circle, right? We call that the cross section of a wire. Okay, we call it a cross section. Basically, when you cut something and look at it, it's called a cross section. Okay, so if I take the cross section of a small wire, okay, I'm going to draw a big diagram. Obviously, wires are thin, not so fat, but yeah. So what these people said is, there are a lot of electrons inside of these metals, but these electrons are moving very randomly. Okay, so maybe one electron is moving this way, another one is moving that way, another one is moving this way, this one is moving maybe that way, this one is moving another way randomly. Okay, so they say that if you take a normal conductor, the electrons inside of that conductor are randomly moving in all directions at any point of time. Okay, there is no order to their motion. Very random. Think of it as your classroom whenever there is no teacher present, right? People are just running around and it's not in their place, kind of like that. Some people standing outside the class, some people standing near the board. Think of it like that. Okay, so because of this, what happens is there is no net proper movement of electrons in or out of the metal. Okay, because of all of this ruckus, there is no net movement of any electrons, right? How many are going this side, those many are going that side, up or down, everywhere else. This is why if you just use wires to connect to a bulb, it will not work. Okay, the electrons need to move in one direction somehow. Okay, that is what happens when you connect a battery to a metal. So if I connect a battery to this metal over here, so what I'm going to do, I'm going to draw another diagram of this, but with a battery attached. Okay, so this is the symbol of a battery. Okay, one big dash, one small dash. This is the symbol of a battery. This is a battery. Okay, what happens then is, because of this battery and the electric field that it generates, okay, we say that a battery generates an electric field. Field is nothing but an area of influence. Okay, so this area, whatever comes under this area, basically whatever is connected to the battery, all the electrons are influenced by this field. Similar to magnetic field, electric field also exists. Any electron that's in that field is immediately going to go exactly in one direction. Okay, so all of these electrons that were random are now going to move in exactly the same direction. No matter where they are going to keep moving in the same direction, which would be this way, from right to left or something. Okay, this is why they say that whenever you use a battery, current is going to pass. Because of this movement of electrons all together at the same time, that is when the bulb, if you attach a bulb over here, since an object is moving, it will have certain energy with it, right? These electrons, when they move, they are going to pass this energy to this bulb. Because of that energy, the bulb is going to glow, right? Without these electrons moving in one direction, there is going to be no power at all, no energy being transmitted. That is why the bulb will not glow if there is no battery and there is no electric field. All right. This is the method or simplified method to understand exactly what is current and how does it work. Okay. To just summarize it, for current to move, we need two things. We need a conductor which has a lot of free electrons, and need a source of power. Okay. Source of power has to be able to make an electric field. So like a battery, right? Now what happens is, in a conductor, there are electrons that are randomly moving in all directions without any order. The moment you connect a conductor to a power source, it generates an electric field. What that electric field does is influences all the electrons to move them in one direction. Now, if I have to follow your classroom analogy, think of it as in your disordered classroom, suddenly the principal or someone walks in or the teacher walks in. Immediately everyone starts running towards the door or towards their places, right? So you're all outside, everyone's running in the front to sit in the place. Think of it like that, right? So because of that power source, all the electrons move in exactly the same direction throughout the conductor. Okay, they kind of move in that loop of the circuit. Okay, from the battery through the conductor all the way around. And anything you put in that circuit, like a bulb or a fan, whatever you put, it's going to be affected by the movement of these electrons, the energy that they carry with them, because anything that moves has energy, right? So that is why a bulb connected to a circuit like this is definitely going to glow, unless the bulb is broken, of course. Right. So this is the basic science behind how electricity works. In the next class, we'll talk a little bit more about the quantitative aspect of electricity. That is, how do you measure it, and what are different units that can define it. All right. That's it for today. Thank you so much for participating. In the next class, we'll just look at a couple more things. If you have any questions, doubts, please drop them in the comments below. And we'll see you again in the next class. Thank you very much.